Searching method in array. Array is the data structure which is named as a variable, and it has, or it can store the data which are in contiguous manner one by one, and those data have to be of the same data type. So if you want to search, say 3 is here, how to search this element? We can have any number, say 1, 5, 6, 3, 9 and 2. Now we need to search 3. So there are various methods, searching methods which we can employ. We have linear search, we have binary search. In linear search, what happens? We start from the first element of the array. We go up till the end and try to find out whether the number which is given to us lies there or not. If it is there, then we say, okay, we have found out the number. In binary search, this is, you can say, the complexity. This is linear search, so the complexity is order of n. But here the complexity reduces to order of log n. How? I'll tell you. Every time we divide the whole data into 2 parts. So every time we divide 2 parts, so we don't have to go from first element to the last element to search for that element. We don't need so much of searching. So linear search, let us see the program. In this, first of all, as I said, each element of the array is compared with the number to be searched in linear order, that is from first to last, and where the number is matched, the position will be displayed. Where this position, say position, this is 0, 1, 2, third. So third position, 3 is there. So we have a function called lsearch. In this we'll pass the array. These are some more parameters. This is again, we have an array. These are certain variables. So we will ask the user to enter the size of the array. If this is the size of array he wants, then we would wish that the elements have to be entered by the user. We start with 0 till n and we enter the numbers. Then we want user to tell us what number he needs to search. So we'll take that item. Now we'll pass in this function this array, size of the array, and the item needs to be searched. And then we will return from this function the index, and we'll show the index. If index is -1, then we just say that the element is not found. Otherwise we'll tell the position, because the array always starts with 0. So we have to add 1 here. Then the position will become like this. This is the first position, this is second position, and so on and so forth. So what this lsearch or linear search is doing, it is taking an array. This is the size of the array, this is the item to be searched. We start with found equal to 0, means found equal to 0 means item is not searched. Then we start with I equal to 0, go till the size of the array, and if ai equal to item, every item has to be searched for this particular item, means every element of the array has to be searched for this particular item. If it equates, then we return I, and then we say found equal to 1. If found equal to 1, this line will not execute, so we break. So we just return I, and this is the index of the index basically. If the item is not found, because if this whole loop goes on and the item is not found, we just say item not found, we return -1, right? I hope you got the idea of linear search. Now let's go back to our binary search. Binary search is doing what? We have, say, this array. Now what we can do here is we can arrange the numbers in ascending order. Say we have 2 here, 5 here, 9 here, 11 here, and 13 here. This is 13. So we need to search, say, for 11. So what we will do, because these numbers are arranged in ascending order, we have to arrange the items in ascending order. This is very essential. Then we start with the center. That is, how many numbers are there? 1, 2, or you can say how many elements are there? 1, 2, 3, 4, 5. So see, we take 5 by 2, and integrally it will come to, this is 2.5, but it will take 2. So in terms of array, it will be 0, 1, 2. So this first, the search is done here. but we have to search for 11. 9 is not 11. So now we know that 11 is greater than 9. So we will skip this part, half part, and we'll only search here. Now we start with this element till this element, and then we search in this half array. So if the array is large, this half is going to be again halved till the time we don't reach the element or we don't find the element. Both the cases are there. So let me show you the program, you will better understand it. This is a binary search program, B search. In this we pass the array, the size and the element to be searched. Now these are the various variables we have made. Then we say cout, enter total elements. Then enter elements in sorted form. We have to enter the element in sorted form. This is very essential as far as binary search is concerned. Then we start with 0 to n, we enter the element, then we ask the user which element you need to search. We take this item, pass it to the function. This is the array, this is the n, and this is the item. If index is equal to -1, we say element is not found. If this function returns -1, we say element is not found. Otherwise, because something will be returned from the function, so index plus 1 we will show. So let us come to this function. This is very important. Now function does what here? This is binary search. This is A, this is size, this is item. So now let me show you like this. In the beginning, in the initial stage, the beginning is 0. So this is BEG. So let me write it as B only. The beginning is 0 and the last is size -1. Say the array size is size, because we know that array starts from 0. For that, this will be size -1. So say this is last L. This will be size -1 initially. Now we have to go to the middle because we know that the element are in sorted order. So what will be the middle? This last plus begin by 2, and these are nothing but the subscript, not the elements. We are not dealing with the elements here. This beginning, last are the subscript. So B plus L by 2. So B plus L by 2 is the mid. So this will be our mid. Let me write it by M. Now if beginning is less than equal to last, if at all beginning reaches beyond last, we know that the item is not found, right? So while beginning is less than equal to last, or while we reach the end of the algorithm, we'll do what? First of all, this is the first point. Now again we have to take the mid, big plus last by 2. If item is in the first case, if the item is found at the middle, we just found the item at the middle, we'll just say that okay, we have found the element, and found equal to 1 we do, because found equal to 0 we have made, found equal to 1, and we break. Otherwise, if the item is greater than this item, say this is say 17 and the item we need to search is 19. So 19 is greater than 17, so we will not search this. But now this is mid, so now the next beginning will be mid plus 1, because mid is already checked. So now beginning will change the beginning. Beginning will be equal to M plus 1. So middle plus 1, and the end will remain same. So beginning will be mid plus 1 and the last will remain same. But if we have an item say 16, we need to search for 16, and this is 17, we know that the item will not be here because this is sorted. 16 will be found from this point to this point only. So now we have to take beginning as beginning, and this mid, last we have to change because we will not go here. Last will be mid minus 1. So mid minus 1. So this is how every time, and once this is done, again if the outer item is not found in between, then we have to half it. Again this will be beginning, this is last, or this will be beginning, this is last. So again half and half and half, and if the element is found, it is okay, otherwise we return -1.